Dig into the core foundations of JavaScript to improve your programs today. Join Kyle Simpson, evangelist of the open web and author of the popular You Don't Know JavaScript book series, as he reveals the deep foundations of JavaScript that will allow you to become a better programmer. By coding along with Kyle in this workshop, you'll learn how the JavaScript engine declares and looks for variables in function and block scope, why coercion is one of the overlooked keys to using JavaScript more effectively, how object wrappers are important for JavaScript's built-in functions, and how Closure helps with modular design and state. Kyle will also show you how objects linked to other objects compares to object-oriented code, how the use of double and triple equal operator impacts performance, which ES6 features can help your script and which could hurt your coding and should be used with caution, and how a deeper understanding of JavaScript can help make you a better communicator and programmer. Here's a glimpse of Kyle in action.
Hi, I'm Kyle Simpson. Most of you know me as Getify online. Well, welcome to the updated version of the old Advanced JavaScript course. This is called Deep JavaScript Foundations. I think it's really important to know not just why a piece of code breaks, also why the code works. And the core foundations of JavaScript are how you get there. First, the type and coercion system, then the scope and closure system and module patterns, the this and object prototype system. These are the things you have to know to make sure that when you write a line of code, you're totally confident why it works that way. This is a deep journey, and I look forward to joining you on that as you learn more about how JavaScript really works. So let's turn our attention now to the second core foundation of JavaScript, the scope, the lexical scope system, and specifically the closure pattern that's built on top of that. This will be our most intense of our curriculum in this workshop. So expect there's a bunch of exercises that we iterate on here, 3 or 4 I think at least, exercises where we iterate on these topics, and there's a lot to get through. So definitely make sure you keep your brain fresh on these topics. If you're watching online or watching later, make sure you go back and review the material so you don't miss out. So where we want to go is first looking at how lexical scope works in terms of nesting, how these scopes nest together. Then we want to talk about a topic. How many of you have heard of hoisting before? Have you heard that term? Okay. So we're going to talk about hoisting. Hoisting's made up. It's not real. It doesn't exist. If you look at the spec, there's no existence of the word hoist because it's not a real thing. It's actually a metaphor for describing how the compiler works. And oh, by the way, did you know JavaScript is a compiled language? We're going to get into all of that stuff. So we're going to talk about some compiler theory, talk about how lexical scope is actually processed and what that means for how we interpret our code. Then we're going to look at closure specifically. How many of you have ever had or given, or maybe both, the job interview, what is closure? Anybody ever had that question or heard that question before? It's a pretty common one. I received it at least once, and I gave it probably 100 times in my capacity working as a developer. And when I would ask people in a job interview, I was brought in because I was kind of the JavaScript expert at my job or whatever. So they always wanted me to come in and like vet the candidate. Do they really know what they're talking about with JavaScript? That's why I was brought in. So I had this set of rigorous questions, and I could tell pretty quickly whether or not somebody had paid any attention to rigorously thinking about the language, or if they would just read some Stack Overflow posts or something like that. So it doesn't take much to filter through that. But I'd ask that question, what is closure? And much more often than not, the answer I would get to that question would be something to the effect of, oh, well, it has something to do with, it's like asynchronous callbacks and like set timeout and click handlers. Okay, can you give me any more information than that? And people would stumble to articulate. And as I said up at the beginning of our course, closure is the most important concept ever invented in computing science. Why is it so important, and yet the most basic of questions can you articulate? If I were to ask you right now, if I put you on the spot and said, tell me what closure is, if you haven't seen this course before or you haven't read my book, how would you answer that question? I think it's important to have a very crisp and specific answer to that question, to know exactly what it is. And it turns out closure is not some brand new thing that I have to teach you. I just have to teach you to recognize where closure already exists in all of your existing programs. Okay, so we're going to look at closure. We want to be really familiar with that and how we use it. And finally, that leads us, our big takeaway, the big punchline here, it leads us to understanding the module pattern. And the module pattern is probably the most important pattern in all of JavaScript in terms of code organization. There is, however, a downside to this approach. To create a function like this, which was a declaration, we had to give it a name, in this case Bob, and that name was included in the enclosing scope, the very same scope that we were trying not to pollute or collide with. So now we have another race condition between us deciding on a name that somebody else won't try to collide with. We need that name because we need it on line 7 to invoke the function. Does everybody follow this reasoning? Like, the good part is that we have a function, but the bad part is, oops, we've got a name that's polluting things. How do we square these two problems? How do we create a scope but not pollute a name? There was a hint given earlier when we talked about function expressions. Remember what happens to the name of a function expression. So what I want to observe first is line 7 is really two separate operations. You recall earlier in the course when we were talking about the way a line 7 would execute is it's first got to resolve the Bob expression, look up whatever value is in it, which in this case happens to be a reference to a function, and then it executes it with the parentheses on line 7. So let's think about it as literally two separate operations. I just put some parentheses there to emphasize the idea that the Bob expression gets evaluated first, and then we call the function. If that's the case, if we can think of that as an expression, what if we just took the function Bob and put it in place of the variable in that expression on line 7? What if we literally just made this from a function declaration into a function expression? All I've done is take that function declaration, Bob, and put it in place of the Bob named expression. Now, something subtle but important has happened because it's no longer a function declaration anymore. It's just a function expression. Why? Because the word function is not literally the first thing in the statement. So it's a function expression, which means that name Bob is not going to pollute the outer enclosing scope anymore. Now all of a sudden that function expression is just going to sit there until on line 6 we have that second set of parentheses that executes it. This pattern has a name. It's called an IFI. It stands for immediately invoked function expression. That parenthesis set there immediately invokes the function expression that we give prior in the statement. If you'd like to read more about where that name comes from, this blog post, I think it's widely regarded that Ben Alman, real big in the jQuery crew, I think he still works for a consultancy out of Boston named Boku. He's widely regarded as coming up with the name for immediately invoked function expression. We needed some name for this pattern. We didn't have a good name, so we're a creative bunch. We just named it the IFI. So turns out this pattern is actually one of the most important in all of JavaScript, or certainly the most prevalent in all of JavaScript. It solves a big need. We need to be able to create scope in various places, but we don't want to pollute them with names. We want that function to exist only for the purpose of scope, and so we really just need it to run once and be done. That's exactly what the IFI does for us. Okay? Some examples of how people use IFIs, and by the way, I always like to name my IFIs exactly for the same reason that we talked about naming function expressions. You should name your IFIs. And if you can't come up with some other good name, at least use the name IFI. Okay? But usually there's some better name to refer to that particular block of scope, and that's especially true if it's an entire file. If the IFI is wrapped around the whole contents of a file, which is how it's most commonly used, you can think about what the contents of that file is doing. Maybe those represent the customer login utilities, in your application. Well, call your IFI customer login utilities or something like that. Give it a name that's more self-descriptive. It'll show up in stack traces, et cetera, et cetera. But what's interesting to me about IFIs is that they really are just regular function calls, which means we can actually sort of import identifiers from the enclosing scope. Here I'm passing in the foo, and I'm giving it a different name. That actually allows me to alias or to rename things to be more convenient to me. So one of the ways that I like to do this, when I wrap an IFI around the contents of, say, a file, I'll pass in the window object, but I'll give it the name global. So the argument will be window down on line 6, but the parameter name up on line 3, I'll call it global. That way, any place that I need to say global dot in front of something, that's a super glaring, obvious neon sign that says this thing is on the global. I just think the word global is better than the word window. Another place where this is often used is with jQuery, for example, or other frameworks that like that $sign variable name. It's a nice short variable name, but lots of people want to use it, so that creates collision if you're using more than one of those utilities. And how many of us love writing Q query throughout all of our code? That's a terrible variable name. So what you can do is pass in the jQuery object or whatever framework of your choice and call it $sign. That way, within the context of your IIFE, it will always predictably be that the $sign points at the thing you wanted it to point at. So it's nice and useful for us to control our lexical namespaces through the arguments and parameters to our IIFEs. Questions about the IIFE pattern? I mentioned that using the IIFE pattern can also be useful inside of loops. This is a big hint to something we'll be dealing with a little bit later in the course. Here I wanted to create a block of scope inside of my for loop. Why? Because I wanted a different j for each iteration. So I made an IIFE inside of the loop, and then I put a var j declaration there, and that j is going to get recreated for each run of the for loop. That'll actually turn out to be really useful when we talk about closure later. So we can put these IIFEs literally in any place that we could put a statement if we want to create some scope there. It's not as nice and clean as, say, a block, and we'll get to block scoping in just a moment, but it is the standard by which we've created these blocks of scope as we just make these IIFEs.
So I have a question. Does the compiler actually create like a variable for the IIFE, or how does that work? Or just completely evaluates it in the runtime?
Yeah, well, this is definitely still going to get handled according to all the rules that we talked about, the theoretical rules that we talked about how compilers work and how JavaScript is going to be compiled. So it would run across this function. It would see that there was a name identifier there. It would need to step into that scope. It would need to create a bucket. It's called a lexical environment, but it would need to create a bucket, like a blue bucket, and the var j would be a blue marble that was stuck in all of that stuff would still happen. But it is true that the JavaScript engines can see stuff like this and figure out if there's a shortcut that they could do to maybe not have to create a full lexical environment if they know it's just going to only be there for a short period of time. So there's always a reality difference. There's always a difference between what we theoretically say happens conceptually and what physically happens. And I can't tell you what physically happens because I'm not a browser developer. I don't know what they actually do. But conceptually, this runs through exactly the same process as any other function.
So in this case, will there be 5 buckets for the IIFE?
Again, conceptually, we're going to be recreating a new bucket each time we loop, right? But practically speaking, the engine might be able to figure out, oh, you're going to reuse this scope in each loop. Maybe I'll just create one, or maybe I don't even need an environment. I don't know how they actually do it. That's an implementation question that would be best passed along to an engine developer. But conceptually, this would be 5 separate buckets. And we really should keep our attention on the concept rather than getting too worried about the implementation, because Firefox may do it differently than Chrome, who does it differently than Edge. Who knows, right? We should focus on the concept, and the concept is we get a separate variable. And we do that when we want a separate variable. If I didn't have the IIFE there, if I just said var j on line 2, how many j's would there be? Just one, right? Because at compile time, we'd find the var j, we'd attach it to the enclosing function scope, which would have been, in this case, the global scope, right? There's only going to be one of those j's. Let's say we're in a situation where we want a j for each loop. This is how we have to do it. Make sense? So think about the conceptual requirements of your code and less about the nitty-gritty of how an engine might implement it. This example is typically used to show how people gloss over the topic of closure and don't fully understand it. It's not usually done with timers. Usually it's done with like click handlers on buttons on a form or something like that. But the idea here is that we're thinking we're getting a new I for each iteration. And so when we close over that I on line 3, that it's going to preserve the 1, 2, 3, 4, 5 value that it should have. So at the 1 second mark, we should get I1. At the 2 second mark, we get I2, I3, I4, I5. That's the spirit of what we're trying to accomplish with this code. But it doesn't work. When you run this code, turns out it'll print 66666. Why? Well, there's two reasons why. There's a surface reason why, and there's a deeper reason why. The surface reason why is, well, of course, I is 6 at the end of the loop.